Hello champion, welcome to your JAMB Chemistry Blast. My name is Omotola Fayomi and today we are conquering atomic structure and periodicity, two of the most consistently tested topics in JAMB Chemistry. Every single year, JAMB asks about subatomic particles, electronic configuration, periodic trends, and isotopes. In the next few minutes, you will master all of them. Stay with me from start to finish. This is the kind of revision that transforms scores. Let's go. Your A grade in JAMB start right now. Every atom is built from three subatomic particles. Protons carry a positive charge, mass of 1, and live in the nucleus. Neutrons have no charge, mass of 1, and also sit in the nucleus. Electrons are negative, almost massless, but just 1 over 1840 of the proton mass and orbit the nucleus in the shell. Now, two critical definitions JAMB test every year. The atomic number Z equals the number of protons. In the neutral atom, Z also equals the number of electrons. The mass number A equals protons plus neutrons. So the number of protons is simply A minus Z. Sodium 23, that means it has Z 11, A 23. So neutron is 23 minus 11 equals 12. Simple. Remember, it is the number of protons that defines which element you have. Change the protons, you change the element entirely. Let's decode the standard atomic notation. The mass number A goes top left, the atomic number Z goes bottom left, the element symbol X is in the center. So sodium 23, written properly, is 23 on top, 11 on the bottom, Na. The atomic number 11 tells us 11 protons and 11 electrons. 23 minus 11 gives 12 neutrons. That's all the information you need. Now, isotopes. This is a guaranteed topic. Chlorine has two isotopes, chlorine 35 and chlorine 37. Both have atomic number 17. So both have 17 protons and 17 electrons. But chlorine 35 has 18 neutrons, while chlorine 37 has 20 neutrons. The definition of isotope is that isotopes are atoms of the same element, same atomic number, or different mass numbers, meaning different numbers of neutrons. Because they have the same electrons, they have identical chemical properties, but different masses means different densities, melting points, and physical behavior. Now we learn how electrons arrange themselves around the nucleus. They fill shells from the inside outward. The maximum capacity of each shell follows the formula 2n squared. Shell 1, 2 times 1 squared equals 2 electrons maximum. Shell 2, 2 times 2 squared equals 8 electrons maximum. Shell 3 equals 2 times 3 squared equals 18 maximum, but in practice fill to 8 before 3 discs of shell is used. Now let's fill some configurations. Sodium Z equals 11, 2 electrons in the shell 1, 8 in shell 2, 1 in shell 3, written as 2, 8, 1. Chlorine Z equals 17, 2, 8, 7. Calcium Z equals 20, 2, 8, 8, 2. 4 shells, so period 4, group 2. Here is your golden rule for JAMB. The number of occupied shells tells you the period. The number of valence electrons tells you the group. 2, 8, 7, 3 shells, period 3, and 7 valence electron equals group 7. Done. Now we go deeper. The subshell model. Within each shell, electrons occupy subshells S, P, D, and F. The S subshell holds 2 electrons, the P subshell holds 6, the D subshell holds 10, and the F subshell holds 14. The Hofbauer principle says fill from lowest energy upward. 1s fills first, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d. Notice that 4s fills before 3d. This trips up many students. Untrue. Another rule: in any subshell, fill each orbital singly before you pair electrons up. What about Pauli's exclusion principle? Each orbital can hold maximum 2 electrons, and they must have opposite spin. For sodium, 1s2, 2s2, 2p6, 3s1. The last electron is the valence electron. For iron is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. Iron is a d block transition metal. 3d6 gives it variable oxidation states of +2 and +3. The periodic table is organized in a beautiful and logical way. Let me show you the pattern. Periods are the horizontal rows. There are 7 periods in the periodic table. The period number tells you how many electron shells the atoms have. Period 1 has 2 elements, hydrogen and helium. Period 2 has 8 elements. Period 3 has 8 elements. Groups are the vertical column. There are 18 groups. The group number tells you how many valence electrons are in the outermost shell. Group 1, the alkali metals, the lithium, the sodium, the potassium, all have 1 valence electron. Group 7, the hydrogens, fluorine, chlorine, bromine, all have 7 valence electrons. Group O, the noble gases, helium, neon, argon, have full outer shells and are completely unreactive. Why do elements in the same group have similar properties? This is because they have the same number of valence electrons, and it is those outer electrons that determine all chemical behavior. Now we tackle periodic trends, and JAMB loves this. Memorize this pattern and you are guaranteed marks. Trend 1, atomic radius. Across a period from left to right, atomic radius decreases. Why? Because we are adding more protons to the nucleus without adding new shells. More nuclear charge pull the electrons inward. The atom shrinks, going down a group. Atomic radius increases. Why? Because each new period adds a new electron shell. The atom gets larger, so sodium is larger than chlorine. Same period, sodium is to the left, but sodium is smaller than potassium. Same group, potassium is lower. Trend 2 is that the first ionization energy, which is the minimum energy needed to remove 1 electron from the gaseous atom. Across a period, ionization energy increases. Smaller atoms with more protons hold their electrons more tightly. Down a group, ionization energy decreases. The reason is that more shells mean the outer electrons are farther from the nucleus and easier to remove. JAMB key fact is that atomic radius and ionization energy are opposite trends. Across the period, when one goes up, the other goes down. Now 2 more vital trends. Electronegativity measures how strongly an atom attracts bonding electrons. On the Pauling scale, across the period from left to right, electronegativity increases. Down a group, electronegativity decreases the most. Electronegative elements in the entire periodic table is fluorine at 4.0 on the Pauling scale, then oxygen at 3.5, nitrogen and chlorine at 3.0. JAMB question alert is that which is the most electronegative element? Is always fluorine. What about metallic trend? This is how metallic an element behaves. Metals tend to lose electrons easily. Across the period, the metallic character decreases as we go from metals on the left to non-metals on the right of the periodic table. Down a group, metallic character increases. Elements lower in a group lose electrons more easily because the outer electrons are farther from the nucleus. Overarching logic, everything in periodic trend comes down to 2 factors: nuclear charge and electron shell distance. Master those 2 and you can reason out any trend on the spot. Why is the atomic mass of chlorine 35.5, not 35 or 36? This is the isotope calculation. The relative atomic mass is a weighted average of all the naturally occurring isotopes. The formula AR equals the sum of each isotope mass times its percentage abundance divided by 100. Let's use chlorine for example. Chlorine 35 makes up 75% of all chlorine atoms. Chlorine 37 makes up 25%. AR equals 35 times 75 plus 37 times 25, all divided by 100. That's 2625 plus 925, which equals 3550 divided by 100 gives 35.5. Exactly the value you see in the periodic table. The second example is boron. Boron 10 is 20%, boron 11 is 80%. AR equals 10 times 20 plus 11 times 80 divided by 100. 200 plus 880 equals 1080. divided by 100 gives 10.8 grams per mole. JAMB has tested this calculation multiple times since from years back. The formula is simple: multiply mass by abundance and then add them up. Divide by 100. Never forget. What about the noble gases? The most stable and non-reactive elements in existence were helium has 2 electrons, a full outer shell, the duplet. Neon has 2 8, a full second shell octet. Argon has 2 8 8, a full third shell octet. Because their outer shell are completely full, they have absolutely no desire to gain or lose electrons. This is why they are called noble or inert gases. Now here's the key insight. The octet rule: all other atoms react chemically in order to achieve the same full shell configuration as noble gases. So then, for example, has configuration 281. It has one valence electron. It loses that one valence electron to become Na plus with configuration 28, just like neon. Chlorine on the other side has configuration 287. It needs one more electron to complete its outer shell. It gains that one electron to become Cl minus with configuration 288, just like argon. The JAMB shortcut here is that when you have less than 4 valence electrons, the element loses them to form a positive ion. More than 4, the element gain electrons to form a negative ion. Can you try and stop the clock? It's practice time. And element X has electronic configuration 287. Which group does it belong to? And what ion does it form? You have your 4 options on the screen. Just try and answer it in the comment section. The answer is C, group 7. It forms X. Here is the reason. The configuration is 287. Count the last number 7. That is the valence electron, which is 7. 7 valence electron means group 7, the halogens. Now, does it gain or lose electrons? 7 is more than 4, so it gains electrons. It needs just 1 electron more to complete the and reach 288, the argon configuration. So X gains 1 electron and becomes X minus. The element is chlorine. Z equals 17. If you got that, brilliant. If not, you know now exactly how to solve it. Write the strategy down. Last number in the configuration equals group. More than 4 valence gain electrons. This is the second question. This time a calculation. An element has 2 isotopes. X64 has 69% abundance, X66 has 31% abundance. Calculate the relative atomic mass. There are options on the screen, and you need to just place your answer in the comment section. Use the formula AR equals mass times abundance added or divided by 100. Answer in the comment section. As I've said, the answer is 64.6, and this is how it works. 64 times 69 equals 4416. 64 times 31 equals 2046. Plus, add them together, you have 4416 plus 2046 equals 6462. Divide all by 100, you have 64.6. 64.6. The element X is actually copper with relative atomic mass approximately 64. 2 JAMB question answer, 2 different skills tested. Identification from configuration and isotope calculation. That's just we just did. If you got both right, you are ready for JAMB. If you got one wrong, review that slide and practice one more time because before your exam. And here it is. You complete atomic structure and periodicity sheet. Screenshot this right now. Save it, print it, paste it where you study. Every concept we cover today condensed onto one slide. Atomic number Z equals protons equals also electron in neutral atoms. Mass number A equals proton plus neutrons. Neutron is A minus Z. Isotope same Z, different heat, different neutrons. Relative atomic mass means multiply mass by percentage, add them up, divide by 100. Shell capacity 2n squared. Valence electron equals group number. Trends like electronegativity increases across period, ionization energy increases across period, atomic radius decreases across the period. All trends reverse going down. A group cheat sheet is worth hour of revision in one screenshot. Share it with every chemistry student you know. You just crushed it within these few minutes, and with the slide presented right there, you have now fully revised atomic structure and periodicity for this year. JAMB, subatomic particles, electronic configuration, isotopes, periodic trends, ionization energy, electronegativity, relative atomic mass. You cover all of it and that is not study, that is power. Now I need you to do 3 things for me. 1, like this video right now. It takes 1 second and it helps more students to find this content. 2, subscribe and hit the notification button so you never miss another JAMB Blitz. 3, share this with your study group. If it helped you, it will help them. Drop a comment below in the comment section. What is your JAMB Chemistry target score and what topic should I cover next? Remember, every element in the periodic table was discovered by someone curious to ask why, and you are that curious student today. The periodic table is no longer your enemy, it is your weapon. Now go use it, ace your JAMB, and come back for the next session. You've got this. Morph, cheers.